Welcome to another video on estimating seasonal variation. In our previous video, we looked at estimating seasonal variation using the additive model. And in this video, we are going to use the multiplicative model to estimate seasonal variation and also to do our forecasting. So let's look at the steps you would have to follow if you want to use the multiplicative model. The first step is to calculate the trend in the data, either using the moving averages or by using the regression method. Then you calculate the seasonal index. How do we calculate the seasonal index? The seasonal index is calculated by your actual data divided by your trend value you found in I. Then you find the average of the seasonal index. Here, if the sum of the average is not equal to the number of seasons per year, adjust them as follows. So how do we adjust them? So the adjusting factor is given by the grand average divided by the average. That's how we adjust the seasonal index. When you're done, you deseasonalize the data. Your deseasonalized data is equal to your actual data divided by the seasonal index or the adjusted seasonal index. Also, we are also going to use the seasonalized data to find a new regression equation, which we will be using for forecasting. So let's try this example here. The table below shows the sales of new cars by quarters during a period of 3 years. Use the moving average method. Thus, we have to use the multiplicative model to determine the deseasonalized sales and establish the trend equation. Also estimate the sales to be expected for the 4 quarters of 2017. So this is how we go by. So for year, you have the year over here. You have 2014. Then we have the quarters, quarter 1, quarter 2, 3, 4. Then when you come to 2015 to we have quarter 1, quarter 2, quarter 3, and quarter 4. 2016. So we have quarter 1, quarter 2, quarter 3, and quarter 4. So now the values, that the sales, which is your Y, 55. So have 7661, 77, 5465, 5281, 5983, 7893. Alright, so you have to use the method of moving array. We are also going to move in 4. So for period moving average, and because it's an even number, define for period centered moving average. So for the 4 period moving average, pick the first 4, 55 to 77. So 55 plus 76 plus 61 plus 77, and the average is 67.25. You write it in between 2 and 3. 67.25. Then we drop the first one and pick the next one. That's from 76 to 54. 76 plus 61 plus 77 plus 54. Also find the average, which is 67. Write it in between 4 and 3. 67. Then we also begin from 61 to 65 and find the average. 64.25. Then the next one will be from 77 to 52. 77 plus 54 plus 65 plus 52. The average is 62. Then from 54 to 81. 54 plus 65 plus 52 plus 81. And the average is 63. Also begin 65 to 59. 65 plus 52 plus 81 plus 59. And the average is giving us 64.25. 64.25. Then from 52 to 83. 52 plus 81 plus 59 plus 83 divided by 4, it's giving us 68.75. Then we have from 81 to 78. 81 plus 59 plus 83 plus 78. Also have 75.25. Then lastly, we have from 59 to 93. 59 plus 83 plus 78 plus 93. The average is giving us 78.25. Now, because they don't relate or they don't align with a particular time period, there is the need for us to center it. So this gives us the centered moving average. And here we are going to move in two. So for the first one, 62.25 plus 67 plus 67 divided by 2. So giving us, so in between them is a period, that's the third quarter in 2014. So this one belongs to the third quarter, 67.125. The first one belongs to the third quarter in 2014, meaning that for the first two periods, there's nothing for there. The next one is going to be 67 plus 64.25 divided by 2. So relating to quarter 4, 65.625. The next one will be 64.25 plus 62 divided by 2, 63.125. The next one relating to quarter 2 for 2015, which is 62 plus 63 divided by 2, 62.5. We have the next one, which is 63 plus 64.25 divided by 2. 63.625. 64.25 plus 68.75 divided by 2. 66.5. 68.75 plus 75.25 divided by 2. 72. 75.25 and 78.25 divided by 2. 76.75. So we see that for the last two quarters too, we also have nothing there. So now whatever we've got here is our trend. So here is our trend values. Our trend values. Now under the multiplicative model, how do we determine our specific seasonal index or our seasonal index? So our seasonal index is given by your actual Y divided by your trend values. And also for the first two, we don't have anything there. So we are going to start from the third quarter. So for the first one, you have 61. That's the actual 61 divided by 67.125, which is 0.9088. Next one is 77 divided by 65.625, 1.1733. We have 54 divided by 63.125, 0.8555. So the next one will be 65 divided by 62.5, 1.04. 52 divided by 63.625, 0.8173. 81 divided by 66.5, 1.2181. 59 divided by 72, 0.8194. Then lastly, 83 divided by 76.75, 1.0814. Okay, so after finding the seasonal index, we need to find the averages of the seasonal index. Now let's find the averages of the seasonal index. So we have seasonal index here. We have the year and the quarters here. We have 2014, 2015, and 2016. We have quarter 1, quarter 2, quarter 3, and quarter 4. So for a seasonal index for quarter 1 in 2014, we have nothing. Quarter 2 too. So it begins from quarter 3, which is 0.9088, 0.9088. The next one is 1.1733, still have 0.8555, 0.8555, 1.04, 1.04, 0.8173, 0.81, 8173, 1.21, 0.2181. Then for 2016, we have 0.8194, 0.8194, 1.0814, and for the last two quarters in 2016 too, we have nothing there. Now let's find the total, and we find the average. So now we have the total 0.8555 plus 0.8194, 1.6, 1.6749. Average, that's divided by 2, is giving us, so this is the average, 0.8375, 1.04 plus 1.0814, 2.1214, divided by 2, 1.0607, 0.9088 plus 0.8173, 1.7261, divided by 2, 0.8631, 1.1733 plus 0.2181, 1.3914. The average 0.6957. Alright, so under the multiplicative model, when we add these averages, it should be equal to the seasons we moved, and here was 4 quarters. So when we add the averages here, it should give us 4. So now let's add them. 0.8375 plus 1.0607 plus 0.8631 plus 0.6957, which is giving us a total of 3.457. 3.457, which is not up to 4. What do we need? We have to adjust it to 4. How do we adjust it? So we are going to have adjusted seasonal index. Adjusted seasonal index. This is how we adjust it. We are going to pick each of the individual averages. So for the first one is 0.8375 divided by the total, which we had 3.457 times, because we are adjusting it to 4, times 4. So 0.8375 divided by 3.457 times 4, which is giving us 0.9691. 0.9691. The next one will be 1.0607. 0.0607 divided by the total, which is 3.457 times 4. So it's giving us 1.2273. The next one is 0.8631 divided by 3.457 times 4.8631, which is 0.9987. Then lastly, we are going to have 0.6957 divided by 3.457 times 4, which is 0.8050. So which is giving us 4, basically 4.000. Okay, now let's create another column for our ASI. So for the first quarter, we had 0.9691. 0.9691. And for the second quarter, we had 1.2273. And for the third, also was 0.9987. And the last one was 0.8050. When it comes to year 2015 to repeat the same thing, for the first quarter was 0.9691. The second was 1.2273. Third was 0.9987. Then 0.8050. So when you are done finding the adjusted seasonal index, we need to deseasonalize our data. How do you deseasonalize our data under the multiplicative model? It's your actual data divided by the ASI. And now let's find our deseasonalize Y values. Seasonalize Y values. So the seasonalized Y value is given by your actual divided by the ASI. So the first one was 55. divide by 0.9691, which is giving us 56.7537. The second one was 76. Divide by 1.2273, 61.92446. Third one was 61 divided by 0.9987, 61.0794. And the fourth one, 77 divided by 0.8050, 95.6522. 54, which is the value for the first quarter in 2015. 54 divided by 0.9691, 55.7218. You have the next one to be 65 divided by 1.2273, 52.9618. The next one is 52 divided by 0.9987, giving us 52.0677. You have 81 divided by 0.8050, 100.6211. Then when you go to 2016, for the first quarter, we had a value of 59. 59 divided by 0.9691, which is 60.8812. The next one is 83 divided by 1.2273, 67.6281. 78 divided by 0.9987, 78.1015. Then lastly, 93 divided by 0.8050, which is 115.5280. All right. So after deseasonalizing the actual y, we now have to find a linear equation, regression equation, based on the deseasonalized value together with our time, that's t. So now let me create another column for t. So first value in that order, 2, 3, 4, 5, 6, 7, 11, and the last one is 12. So based on these two columns, we have to find regression. So y is equal to a plus 20. For this, you can also use the calculator to solve. So the first y value, the seasonalized y values was 56.7537, 61.9246, 61.0794, 95.6522, 55.7218, 52, 0.9618, 52.0677, 100.6211, 60.8812, 67.6281, 78.1015, 115.5280. Now you can easily find A. So now A is 53.4427 plus the B, which is 2.7899T. So this is our regression equation. Now we are to use this regression equation to find the estimated sales for the 4 quarters of 2017. So bear in mind that here we ended, the T was 12. That was for the last quarter in 2016. So if we were to continue from 2017, the first quarter would have been T of 13, and we are to continue in that order. So based on this equation, whatever value we are going to get is what the seasonalized. So you can see that this one is what the seasonalized values for 2017. For 2017, we have quarter one. So quarter one, T is 13. So 53.4427 plus 2.7899 times the 13, which is giving us a deseasonalized value for 2017 quarter one of 89.7114. And for quarter two, so have the same thing, 53.4427 plus 2.7899. Now for the quarter two, it becomes 14, which is also giving us a value of 92.5013. Quarter three, 53.4427 plus 2.7899 times 15 is equal to 95.2912. Then lastly, for quarter four, 53.4427 plus 2.7899 times the 16 98.0811. So these are the deseasonalized values for 2017. So if you want to we want to seasonalize a value, as in convert this deseasonalized to include the effect of the seasonal variation or the ASI, we need to multiply. We need to multiply these values by their respective ASIs. So let's seasonalize. So you can call this one the seasonalized values for 2017. Quarter one is given by, now let's pick the seasonalized values for quarter one. It's 89.7114. Now this is the deseasonalized. Now how do we convert this deseasonalized into a seasonalized value? We multiply by the respective ASI. So the ASI for quarter one, we had 0.9691. The same thing when you come here, 0.9691. 0.9691, giving us a value of 86.9393. Now let's move on to quarter two. For quarter two, the deseasonalized value for quarter two, 92.50, 5013 times the ASI for quarter two, 1.2273, 1.2273, 92.5013 times 1.2273, 113.5268. Then for quarter three, a deseasonalized value of 95.29, 95.2912. We also multiply by the ASI for quarter three, which was 0.9987, 0.9987 is equal to 95.1673. And for the last quarter, we have a deseasonalized value of 98.0811 times 0.8050, giving us a value of 78.9553. So this is how we use the multiplicative model. So for multiplicative model, we divide the actual by the trend to find the seasonal variation or the seasonal index. We find the average and we adjust, then we deseasonalize. We use the deseasonalized value and a time t to find our trend equation. We use it to forecast. Then we seasonalize them again using their respective ASIs.